Hello friends, it's MoNaCo here. Our first lecture video in our 7th unit. We're talking about solutions in this unit, everything that has to deal with solutions. So after this lesson, you should be able to classify samples according to their physical properties, aligning them with our new vocabulary. Our new practice pack and homework's got a lot of new unit vocabulary that we have to start using and getting familiar with. So our lead in today, as we may have heard of this term solution as it pertains to liquids, okay? We need to clarify the vocabulary surrounding that so that because there's a lot of different possibilities. There's a lot of different types of solutions. So we break up these types into major distinctions, the heterogeneous and homogeneous. Back to the first or second unit we studied, we're going to start recycling that vocabulary. So let's explore all the different ways a solution can work. And we start on our 3rd page of our homework lectures pack with the definition of a mixture. A mixture is a definition of two things or more that are mixed together, but they can be separated by a physical means. So physically can be separated. Now the first type of mixtures, and this is review, are the heterogeneous mixtures. Two or more pure things in different states. So we got varying composition. It's not uniform throughout. The scenario is if you've got a beaker, you might have some particles that are red over here and over there and over here and over there. Then you have other particles that, are physically, you can see the difference between them, okay? You can see the different components of the mixture. That makes it heterogeneous. Now, the suspension is a heterogeneous mixture that clearly separates. So like if we've got muddy water, the mud will separate out. That's really technically called a suspension. So it eventually will separate upon standing. That means sitting still. It's separated by a filtration. Typically, if you wanted to filter the sand and clay out of this water, you pour it through a filter. Relatively large particle sizes in suspension. So we've got like anything from fine grains of sand up to, slightly other things that like to float around in there. So examples of this are like some sand and water, or mud and water, or Italian dressing, right? It separates if you let it sit. So keyword here, standing, sit. So if you let it sit and do nothing, that's called standing. So it will separate by itself. So we are going to move on to the bottom of page 3 here. So a colloid, this is a new word. It's a heterogeneous mixture that does not clearly separate. Okay, so this is like a suspension, but it won't separate. So it's like cloudy. Gelatin is a colloid. Jello doesn't separate by itself. It is what it is. So typically colloids are cloudy. They appear to be homogeneous, but technically they're not. At the atomic level, at the particulate level, at the microscope level, you can see the different parts. They do not settle naturally on their own through time. They can be separated by a centrifuge. You might have seen this in your health science classes. Centrifuges can separate blood. So technically, blood is a colloid because it can be separated into platelets and plasma through a centrifuge. So you can separate blood into platelets and plasma by using the centrifuge, which uses gravity. Now, this separates medium to small particle sizes. So obviously, blood's got extremely small particle sizes, but they can be separated out with a centrifuge. Examples, blood and milk. Milk separates if you let it sit for long enough, or if you put it in a centrifuge, you can get the thick, fatty part of the milk to separate to the bottom and the thinner part to the top. So that's how you get skimmed milk. They kind of centrifuge it out so the heavier fatty parts go to the bottom into whole milk, and then the top part is that skim milk. So we're moving on to page 4 in our lecture pack to talk about the homogeneous mixtures. These are actual solutions. So the heterogeneous were suspensions and colloids. These are actual solutions. So it's two or more pure substances in the same physical state. So it has a constant composition that's uniform throughout, which means looks the same all the way through. Okay? And if we had a picture of this stuff, it would look to be like it was a liquid and have all the same color all the way through. You would not see particles. You would not see chunks here or chunks there. It would look all the same all the way through. Kind of like what we've got here, right? It's green, but it's uniformly green. Now, it looks like it's clear, colored, or colorless water. So that's what's confusing about this stuff, because you look at it and you're like, well, it's clear and it's all the same. It must be pure. Not necessarily. It's got extremely small particle size, like at the atomic level particle size. You can't see them under a microscope. You can't separate them unless by physical means. May exist in any phase. Liquid is the most common. So solutions, we're usually going to be talking about liquids. Sometimes there's a gas and sometimes there's a solid. We'll cover those in a little bit. Some examples: salt water, Kool-Aid, club soda, any kind of soda for that matter, once it becomes flat, is technically a solution. Okay, alcohol is a solution, at least how we consume it here in America. Moving on to the second half of this page, an alloy. Here is an interesting type of solution. So one of the materials is a metal. Okay, so we're not talking about liquids and solids mixed together to make a solution. We're talking about alloys. So this is a whole part of human history that was really, really important when humans stopped smashing rocks together and started melting metals together and made tools. So for example, on the left-hand side, we have brass. It's an alloy because you can see here we've got atoms of one color mixed in with atoms of another. Okay, and they're all metals. So we've got ourselves an alloy. Now the other type of alloy is an interstitial alloy, carbon steel. We've got a non-metal, carbon, mixed in with all these metals, iron. Okay, so we got mixtures of metals make alloys. Metals arrange in an alternating pattern with a sea of mobile valence electrons gluing them together. That's a connection back to chemical bonding. So metals are sea of mobile electrons gluing all of them together. So examples of brass, steel, any of the metals that we come into contact with in our lives and on a daily basis are most likely alloys, because pure metals tend to be kind of reactive. Now, you should be able to identify some of the different combinations of materials according to their properties. So heterogeneous, homogeneous, colloids, suspensions, solutions. Okay, these are all the things that we were talking about in this video here. Now, there's no practice packet, no quiz associated with this. So you can go ahead on your checklist and say, okay, I got my lecture notes number 1 all finished. Check that off, sign it, stamp it, and move on to lecture number 2. That's what we're going to do. Thank you.